Welcome to problem 3 video on mesh analysis. In this video, we'll be analyzing the Wheatstone bridge. You should be familiar with this circuit already. We have solved it twice using Kirchhoff's law and nodal analysis, and this time around we will be solving it using mesh analysis. Now, the goal in this video is to find the current flowing through each resistor, and we'll be doing that using mesh analysis. In order to do that, the first thing we want to do is hit the like button and subscribe. Hit the notification bell too. Then we can proceed to solving the problem. I'm not joking. Hit the like button and subscribe. Oh, thank you. Now the first thing we're going to do is we identify our meshes. This will be mesh 1, mesh 2, and mesh 3. Then we assign current to each mesh. So this would be I1. Let's make this mesh current I2, and we make this mesh current I3. Okay. Now at mesh 1, we write a KVL equation. Now we start from here and we proceed, and we have the 1 ohm resistor, and we have two currents flowing through the 1 ohm resistor: the current in mesh 1, which is I1, and the current in mesh 2, I2, which is opposing it. So we have I1 minus I2 multiplied by 1. Then we have this second resistor. We have current I1 flowing through it and current I3 opposing it. So we have plus 4 open bracket I1 minus I3 equals okay, and then we come here and we meet this 10 ohm, this 10 volts power source minus 10. Then we equate everything to 0. We can then rewrite this as R. That would be 5I1, okay, minus I2, okay, then minus 3, minus 4I3, and everything would be equals to 0. And we can call this our first equation. Okay, then we can proceed to the second mesh and write a KVL equation there. So that would be mesh 2. Okay, then we start from here, and the current flowing through this 2 ohm resistor would be I2, because it is not associated with any other mesh. So would have 2I2. Okay, then we come down here and we have the 3 ohm resistor, and it has two currents flowing through it. That would be I2 and I3. So that would be plus 3 into I2 minus I3. Then we come here and we have two currents flowing through the 1 ohm resistor, and we would have plus 1 into I2 minus I1. Then we equate everything to 0 using KVL. Then we can write we can simplify this further, and we would have 2, 5, 1. That would be 6I2, okay, plus okay, minus 3I3, okay, minus I1 equals 0. Then we can call this our second equation. Okay, then we can proceed to mesh 3 and write another KVL equation there. And then at mesh 3, so we start here and we have I3 and I2. So we have 3I3 minus I2. So we have 3 open bracket I3 minus I2 plus then we come down here, then we have 5 into I3 plus 5 I3. Then we come down here, we have 4 into I3 minus I1 plus 4 into I3 minus I1. Then we equate everything to 0. Then we can rewrite this, and we have 3, 5, 4. That will be 12 I3. 12 I3. Then we have minus 3 I2 and minus 4 I1 equals 0, and we can call this our third equation. We can then put this into our calculator to solve it simultaneously, and then we would arrive at the value of I1 to be equals to 3.44 amperes, and the value of I2 would be equals to 1.31 amperes, and the value of I3 would be equals to 1.48 amperes. But you see, the goal here is to find the current flowing through each resistor. So if we want to find the current flowing through the 1 ohm resistor, now we have I1 flowing through it and I2 opposing it. So the current flowing through the I1 resistor in this direction would be I1 minus I2, which would be 3.44 minus 1.31. Okay, that would be 2.13 amperes. Then the current flowing through the 2 ohm resistor would be in this direction would be the I2 current, which would be simply be 1.31 amperes. The current flowing through the 3 ohm resistor, say in this direction, would be I2 minus I3, and in this case that would be I2 minus I3, which would be that's 1.31 minus 1.48 amperes, and that would be equals to minus 0.17 amperes. And this negative sign means that we have assumed the wrong direction for our for the current flowing through our 3 ohm resistor. So we should have assumed the opposite direction. But since we've given it a negative sign, we're still cool. And then the current flowing through the 5 ohm resistor would be equals to 1.97 amperes. And that would be all for this video. Please do not forget to hit the like button and subscribe. Hit the notification bell. If you can, do share it with others. See you in the next video. Bye.